All right, so here we are, hopefully in the last section of our ACT packet, and a lot of these are area and perimeter problems. So I'm going to be going through the formulas for the different shapes, and hopefully some of that will stick for when you need it for the ACT. So our first shape is a parallelogram. And when we find the area of a parallelogram, we multiply base times height. And when we find the perimeter, we add all sides. So we'll have 2 of the same width, and we'll have 2 of the same length. So we'll go 20 plus 20 plus 24 plus 24. So I'm going to go ahead and figure out the perimeter, and then that way I can narrow down some of my choices. So 20 and 20 is 40, 24 and 24 is 48, 40 plus 48 is 88. So I can see that it's going to be A or D, and C and B are out. And then the last thing I need to do is to find the height so that I can find my, my base is 24 and my height is some other number. And it's not given, but they tell me I have a 60-degree angle here, so that this is a little way to see if you know about the rules of 30, 60, 90 triangles. So the rule of a 30, 60, 90 triangle is that the hypotenuse, if you take half of that, you can find out what the short side of the 30, 60, 90. Then if you take that short side times radical 3, you can find out what the long side is. So 10 radical 3 is the height of this triangle. So I'm going to multiply that in my calculator times 24. 10 radical 3 times 24. And I get 415.7. So that is choice A. Now, how could we have done that if we didn't know this 30, 60, 90 rule? Well, let's see what 10 radical 3 is. 10 times radical 3. So our height is around 17. So if I had to estimate my height, I would estimate that it's some number less than 20. So 20 times some number less than 20, and I could pick, let's see, 20 times 15. Yeah, you'd pretty much have to estimate. If you do 20 times 15, you get 300. If you do 20 times 17, you get 340. You do 20 times 18, 360. Well, hang on a second. Oh, sorry, not 20. We want to do 24 times all those numbers if we're estimating our height. So 24 times 15 is 360, and 24 times 17 is 408. And then 24 times 18 is 432. So I'm looking at 346 here, and you know, that just seems too low. So if I'm estimating, the best estimate is going to be to go with choice A also. All right, so I'm looking here at this next shape. Since I have diagonals and I have lengths that are the same, I am dealing with a rhombus. And the way we do height in a rhombus, or rhombus is really a parallelogram. So if you know the base and the height, you can find the area of the rhombus that way. But if you don't know the base and the height, you can do 1/2 times diagonal 1 times diagonal 2 is the formula for the area of a rhombus. So diagonal 1 is 16 and 16, or 32. And diagonal 2 is 21 times 21, or 21 plus 21, which is 42. So I'm going to multiply this out in my calculator, and I get 672, which is choice A. Next shape, this is called a composite shape, where you have a couple of different shapes added together. And so we're going to find the area of the figure by adding the two of them together. So I'm going to take my rectangle and find its area, and I'm going to add the area of the triangle. So a rectangle is length times width. The triangle is 1/2 base times height. And I'm going to see if I can find these missing numbers so I can plug them into my formula. So my width of my rectangle is 8. My length of my rectangle is 7 plus 6, or 13. Then my base of my triangle, I'm going to take this 14 and I'm going to subtract off this 8 right here. So that's 6. And then the height of my triangle is also 6. So 13 times 8, I get 104, and 1/2 times 6 times 6, or half of 36, is 18. So I'm going to add those together, and I get 122 altogether. So that's choice D. And then the next one, number 60. So this shape is basically a rectangle. If I take the whole rectangle and I subtract off the circle, and that'll get me the space that's left over. So the area of my rectangle is going to be length times width, and the area of a circle, so since I've got 2 half circles, that's going to add up to 1 whole circle. So I'm going to take the area of the circle, pi r squared. So my length of my rectangle is 32, and my width is 24. And my radius of my circle, and we have to remember a radius is just halfway across, so that's going to be 12 squared. So I'm going to do 32 times 24, and I get 768, and then I'm going to subtract. I'm going to do pi r squared. Let's see, and then my answer's in a decimal, so I can put in my pi times 12 squared. And that's 452.39, we'll say. So I'm just going to do 768 minus my previous answer, and I get 315. So that's choice D. So these area and perimeter problems really aren't bad if you know the formulas. So it's really just a matter of knowing the formulas. So here we've got some 3D shapes. So we're probably going to be finding either volume or lateral area. So what lateral area is all the outside pieces. So I am going to figure out what I have and then what I need to add together to find the lateral area. So for my pyramid, what I've got at the top is to just find the 4 triangles. So I'm going to find the area of the 4. Well, I'll find the area of 1 triangle, and then I'll multiply it times 4. And then I've got the faces of my cube, so I'm going to add, and I have all of them except the top. So I have the 4 sides plus the bottom. So I'm going to take 5 times the area of this square. So it says it's a cube, so that means I have 10, 10, and 10. So my triangle is going to be 1/2 base times height. And I'm going to have 4 of those. And I have 5 of my side times side, or s squared. So plug in what I know. My base of my triangle is 10. My height is 8. And each side on my square is 10, so 10 times 10. So 4 times 1/2 is 2, 2 times 10 times 8 is 40. And 5 times 100 is 500, and what happened? Something went wrong. Let's see, so my triangle, the base is 10, the height is 8. So half times 10 times 8, half, oh, here we go. Okay, half of 80 is 40, 40 times 4. I forgot to multiply by 4. So I need to add 160 plus 500, and that gives me 660. So this is a reason why I love multiple choice tests, because if I make a little goof, my answer won't be there, and I can go back and fix it. All right, so that is lateral area. Now let's look at what we have here, a pyramid. And we're finding surface area of the pyramid. So we have all these guys are the same. So to find, and this is one of those things that this is a challenging problem. You have a lot of pieces to it. So to find the height for a triangle is you've got to kind of be able to visually see that those 16s are not the height. The height is always an altitude. So I've got to break this triangle apart and do some Pythagorean theorem to find my height. So I've got a squared plus b squared equals c squared. And my c is the 16. That's the hypotenuse. So I'm going to take 16 squared minus the 9 squared. And I get 175, and the square root of 175. So this height is about 13.22. And I've got 1, 2, 3 of these guys. And then on the bottom, that's a different triangle. So pyramids can have a different size base. So I'm going to add 3 of the triangular bases, and then I'm going to add the area of the bottom, which is separate. And now to find the area of my bottom side, I'm going to have well, I don't know if they give me enough information to find the area of the bottom. So I'm just check my answers real quick for this guy. And that's number 62. All right, so as I'm reading about this problem, it says this is a regular or equilateral triangle. See, that's where I feel like they didn't tell me. Oh, it does. It says it's a regular pyramid. So that's how we know that's an equilateral triangle. So that is the piece that I was missing there. So I'm not using the formula that they gave me. I'm just adding together all the pieces. So I'm going to go ahead and I'm going to find the height of my base. So I'm going to do another Pythagorean theorem here. I'm going to do 9 squared plus b squared equals 18 squared. So 18 squared minus 9 squared, and I'll take the square root of that. I get 243 is 15.6. So the height down here is 15.6. So I'm going to go back and use my formula. I'm going to go 3 of the side faces, which is 1/2 times 13.22 times, sorry, my base, that's the height, and then my base is the 18. And then for my base, or my bottom triangle, I'm going to go 1/2 times 18, and then my height was 15.6. So I'm going to multiply all this stuff together. So I'm going to go 3 times 1/2, and I just put 0.5, times 13.22 times 18, and I get an answer. I'm going to add all that to 1/2 times 18 times 15.6. Altogether, 497.34. And A is going to be the closest to that. Oh gosh, and I forgot to put my camera back on. So here's all my work for that. Here's where I figured out the height of the base triangle, and I got 15.6 for B. And then here's where I substituted everything in and found the solution. All right, so for number 63, the lateral area of the cone. So that is not the bottom, that's just the circular part. And there's a formula for that. And so we're going to look on the answer key for our formula. Normally on the ACT, they would give you the formula for something weird like a lateral area. So the lateral area on a cone is pi RL, and L stands for the slant height. And so that is given here. The slant height is 7. If you were finding the actual volume of that cone, you would use the height. So you would use a Pythagorean theorem to find out this central height here. But we just need pi RL, and everything is given. So that's pi times 5 times 7. And when I am doing, if the decimals are rounded already on the ACT, then I'm going to use my pi button, and that's going to give me all the decimals of pi. So 109.95, and that's going to be choice B is my best choice. All right, so number 64, if a plane intersects a sphere, so it contains the center of the sphere, then that intersection will sometimes be a great circle. So I'm going to use, I happen to know there's a picture of a sphere on the back side. So what they're saying is a plane intersecting a circle, and it will be a great circle, which means the largest possible circle. So, and that is true, because if I rotate and this plane intersects it anywhere, as long as it's always going through the center, it's going to be always a great circle. So that's going to be choice C. That's my own SARFI logic. And yes, that matches with the answer key also. So that's just the definition of a great circle. So to me, when they ask you these plane intersecting a shape, you just have to be able to visualize the shape and visualize a plane cutting that shape. So all the radii of the same sphere are congruent, and the definition of a radius is that it comes from the center to the outer edge. And yes, that is the definition of a sphere. So I'm going to check my answer just to be on the safe side. Yes, so that is correct. Number 66, find the surface area of the sphere. Now, when they tell you to use 3.14 for pi, they're telling you not to use your pi button. So we are going to look for the formula of the surface area of a sphere on our answer key. And spheres always have a fraction in their formulas. So this is number 66, or a fraction or some kind of a multiplier. So surface area is going to be r squared. When we have volumes, that's going to be when we have things that are cubed. So here's our formula for the surface area of a sphere. And so now it's just a substitution problem. And the radius, so they give me the diameter is 6. So the tricky part is I have to use a radius. So 4 times pi times 3 squared is 8 is plug-inable. So that's 113.04. So that's going to be choice A. Number 67, surface area of a sphere if the circumference of a great circle is 43.96. So I'm going to use this previous picture to do my labeling, so you can see where these things come from. So the circumference of a great circle, that would be this circle here, is 43.96. So in order to find surface area, what do we need? We need 4 pi r squared. So we need to know the radius. So if I know that this circumference, the formula for circumference is 2 pi r. So I can divide by 2 pi on both sides, and I'll use my calculator to get what the radius is. So I'm going to go 43.96 divided by 2 pi, and my radius is 7. So now I can plug 7 into my surface area formula. 4 times pi times 7 squared. 4 times, and they did tell me use 3.14 for pi, so I love my pi button, but when they tell me what to use, I'm going to use that, times 7 squared. I get 615.44. So that's right there at choice D. In number 68, we're doing a snow cone with a paper cone that is 8 centimeters deep and a diameter of 5. So I always draw my geometry pictures. So diameter of 5, so that's all the way across, and it's 8 centimeters deep. So that is the height. And then we get a spherical scoop. And so our scoop of, ice is 5 centimeters in diameter. And all the ice melts into the cone. Okay, will the cone overflow? So what they're asking about is, what's the volume of the sphere? And what's the volume of the cone? And so really, you just need to find the volume of both and then compare. So we are going to find the volume of the sphere, which is, I believe it's 4/3 pi r cubed. I always have to check these. Normally, the deal is they don't give you a formula sheet on the ACT. A lot of times they give you formulas, but not a formula sheet. So it's best to go in with them memorized. So we've got the volume of the sphere is 4/3 pi r cubed. And the volume of a cone is 1/3 of pi r cubed times the pi r squared times the height. So it's like 1/3 of the top, which is the circle, and then you got to multiply the height in there. So these are the two things we're going to find, and we're just going to compare them. So first things first, they gave us this. They gave us the diameter was 5, so we have to not be tricked by that. We need to make sure we cut that in half to be the radius. So I'm going to do the volume of my sphere down here, 4/3 times pi times 2.5 to the third. And I'm just going to use my calculator for that. So 4/3 times pi times 2.5 to the third, and somewhere, tell you what, I'm going to do my fraction in parentheses like I'm supposed to. 4/3 pi times 2.5 to the third. Let's see what happens there. All right, so that's 65.45. And then 1/3 times pi times 2.5 squared times the height, which is 8. So that's 52. The volume of the cone is 52.36. So as I'm comparing, there's more volume in the ice than there is in the cone. So the answer is, volume of the ice, the answer would be C. And let me just verify that. Yes. Okay, number 69, what's the volume of this sphere? Rounded to the nearest tenth. Are they looking at the sphere up above? Which sphere are they talking about in number 69? All right, that's where I go to my answers again. I think they just left the picture off of this one. So unless you have the picture, you really can't tell that what they're talking about is a sphere with a radius of 12. So I'm just going to, from the answers, just reiterate that the volume of a sphere is 4/3 pi r cubed. So whatever the r is, you just plug it in. And in number 70, congruent spheres have equal surface areas. So if they are congruent, then they always have the same surface area because they have the same radius. And is that it? Is number 70 the last one? Yes. All right. So that's the end. And thank you for watching. And if you did your ACT packet, I really appreciate you trying to get some experience with geometry so that you can be as ready as you can for the ACT.